Yes,
Yes
ma'am.
po.
Okay, okay, sige. I will continue now. Now, just to relate the CRD with LSD. Okay, last time in CRD, we just randomly assigned the treatments to the different experimental units. So we have this illustration here. Okay, and then now for the LSD, it's not just completely randomizing the treatments. So there is this randomization again, but in a systematic way. So how do we do that? Okay. Next, in the next few slides, I will be illustrating on how to systematically randomly assign the treatments to the experimental units. Okay, just to have a picture, ito po yun. Ganito po siya. If you see treatment C here, it should only be seen once in that row and once in that column, right? And then if you see A here, that A must be okay once in that, can be seen once in that row and then in that column. Okay, so I hope you follow. So ito yung expect natin kapag we have this LSD as the design structure. Okay, recall again that what if that I told you, or I asked you about this. What if this nuisance factor, it's not just one factor, so it could be two. So that's why we have to deal with this. We have to apply this Latin square if you have two blocks or two nuisance factors. No, so consider two gradients. So those are the two factors or two blocking factors by using two-dimensional blocking. Okay, of experimental units. Okay, used when experimental units can be grouped according to two sources of variation. Okay, so if you can recall, if we have an ANOVA table, aside from treatment, error, and the total, okay, so the source of variation, we also have block, right? Now for the Latin square, we have additional block. Okay, so medyo nagko-complicate yung ating ANOVA table. So like RCBD, blocks in the LSD must be complete blocks, meaning in one row block, okay, there should be this presence of all treatment levels. Or in one column block, there should be this presence of 4 or complete treatment levels. Kaya complete block pa din siya. Used for small number of treatments, okay? So the disadvantage here is we can only use this if we have small number of treatment levels. Why? Because this will also dictate your number of rows and your number of columns. Okay, so the number of rows and the number of columns and the number of treatments must be the same. Okay, so dapat parehas yung rows, columns, and treatments. An experimental unit should belong to one of the row classifications and to one of the columns. So yun nga, we only see treatment A to that row once lang, and then to that column once lang din. So each treatment must be applied once to each row and once to each column. Okay, so as you can see in the illustration here, kita naman, no, si C, okay, once for row 1 and then for column 1. Okay, application, the same. Ganun pa din sa RCBD. Now, it's just that we consider another blocking factor. So it can be in the agriculture experiment, biological or medical experiments, engineering, or in market research. Then we have this randomization. So the same pattern lang po, yung discussion natin. There's a CRD, RCBD, and Latin square. We have this randomization, then yung ANOVA, and then you have this test of hypothesis. Okay, so obtain a basic T by T Latin square plan. Okay, so you should have this square plan. And then randomize the assignment of row factor. Next is randomize the assignment of the column factor. And then last, this randomization of the assignment of treatment. Okay, so how do we illustrate that? So first, okay, we have this original layout. Okay, so wala pang randomization na involved dyan. So we have this arrangement 1, 2, 3, 4. And then for the rows, 1, 2, 3, 4. And then for the treatments, A, B, C, D, ganun lang. Okay, as you can see. So wala pa po. This is the original layout. And then, what we do next is we generate random numbers, okay, to have this arrangement for the rows, for the row factor. So if we generate random numbers, the smallest number here is 0.375. That has this has this rank 1. And then next, second to the last value is this 0.654. This has rank 2. And then next, rank 3 and 4. So as you can see in the arrangement, we have now 1, 4, 1, then 4. Can you follow? Yung red, para ano, yung red na font, okay, ito yun, red is here. Then 3, then 2, okay, as your rank 4. So ito yung last sa rank, sa row 4. Okay, I hope, no, you can follow. 1, 4, 3, 2. Okay, so that's for the row factor. Of course, you will not use this when you use the star because they have this way not to randomize. And then for the column, we have this lowest value, the generated value, 0.231, no, 0.089, that's the lowest value, generated value. So rank 1, okay? So that's column 2. That's why here we have 2. And the next is 2. This is column 4. So we have 2, 4. And then next, the 3, 3. And then the last rank, column 1. So nag-interchange na yung ating columns. And also the rows, no? Na-carry na yung sa rows. Okay, so the next step is the randomization of the treatments. Okay, so from the rows to columns now to the treatments. How? So we generate again random numbers, and then the lowest value of the generated random number is this one. Okay, has rank 1, and then variety M3. So this is your treatment level 3. Okay, we have M3 here. The next one, next to rank 1 is rank 2. So we have M2, M1. So we have M1 here next to M3. And next we have M2 for this, rank 3. And then lastly, we have rank 4 for M4, this one. So if we have 3, 1, 2, 4 for that column, we should also have 3, 1, 2, 4 for that row, for the first row. Can you follow? So this is it. Now, how about the rest of the cells in the table? Where we have this M2 here? Okay, take note that the preceding treatment is M1. Okay, and M1 has rank 2. So what's next to rank 2? It's rank 3. And that is your treatment level 2 or the M2. So I hope it's not confusing. You just follow the ranks. Okay, and then what's next to rank 2, which rank 3 is rank 4. So this is treatment level 4 or the M4. Then next to rank 4 is, go back to rank 1. Okay, and then we have this treatment level M3. Okay, so if we have this pattern 2, 4, 3, the same in the column, in the second column, we should also have the same pattern for the second row. So 2, 4, 3. Okay, and then how about this? So M4, okay, so 2, 4, and then what's next to M4? We have, okay, M4, it has rank 4. So we now go back to rank 1, which is M3. So that's why next to M4 is M3. And then next is M1. So after rank 1, we have rank 2, which is M1 here. Okay, I hope you can follow. So this is now the way we randomize or randomly assign the treatments, okay, to the experimental units. Okay, so that's it. So as you can see, M3 can only be seen once in column of this, in this column and in this row. Okay, so that's it. Okay, so we're done with the randomization. So we just take note that if we have 2 treatments, we have this original layout, and if we have 3 treatments, we have this original layout, and if we have these 4 treatments, which actually we tried not to illustrate, we have this layout. And then this is what I told you, this additional, okay, source of variation we have for the first block and for the second block. Okay, before we only have treatment and error. And then for the RCBD, we have 1 row for the block. And then now for the Latin square, we have 2 blocks. So we have 2 rows. Okay, so this is now the structure for our ANOVA table. Okay, so the same pattern nga po. We now state the hypothesis. Okay, first, we can use the mu's or the mu1 equal to mu2, okay, or the tau i's, okay. Okay, so for the HO, there is no difference in the mean response among the treatments. Okay, mean response among the treatments. So you can denote this with this mu1 equal to mu2 equal to mu t. And then for the HA, at least one of the treatment levels has a different mean response. Okay, and then test procedure again, F test. Okay, assuming that the assumptions are satisfied. And then the F test, we have this formula, we have this ratio. Okay, for the treatment. Okay, take note, the numerator here is for the treatment. Okay, then reject HO if the F computed is greater than the F tabulated, or we can use the p-value. Then, aside from testing for the treatment means, we also have to test for the differences of this or among this row factor. So the block 1. Okay, so you can use this notation. Okay, rho I equal to 0 for your HO. So there is no difference in the mean response among the levels of the first block or the row classification. And then HA, at least one of the levels of the row classification has a different mean response. Okay, at least one, so naiba from the rest. And then and then the test procedure, we have F test. Okay, take note that the numerator now is different from that testing for the means using the treatments. We have this now for the row. Okay, row factor, we have MSR. And then for the decision rule, reject HO if the F computed is greater than the F tabulated. Or you can use the p-value. And then, okay, we have for the treatment, our treatment levels, we have for the row, and then now for the column. So we can use gamma. Okay, there is no difference in the mean response among levels. So pag no difference, gamma J is equal to 0. Versus HA, at least okay, one of the levels has a different mean. Okay, so that's gamma J not equal to 0. F, test pa din, then we have this different ratio, yung numerator, na iba na. So for the MS column classification. And then we reject HO if the F is greater than the F tabulated, or we can use the p-value.